Hello, calculus fans. Okay, so let's try a problem where we're actually going to find absolute maximum and absolute minimum values. The function that we're going to use is f of x equals x squared plus 16 over x, and we're going to do this on the interval from 1 to 3. So anytime we want to look for absolute maximum and absolute minimum values, we want to use the closed interval method. Now it is worth noting that the function that we're given is continuous on the interval from 1 to 3. That's the interval that we're given. So we can go ahead and use the closed interval method. The closed interval method is only applied to continuous functions defined on closed intervals. Okay, so our first step is to find the critical numbers. Now we want to calculate the derivative. So let's rewrite the original function as x squared plus 16 times x to the minus 1 power. So instead of having it as a fraction, we have it as a power function. That way we can use the power rule. Now let's compute the derivative. All right, so according to the power rule, the derivative is 2x minus 16x to the minus 2. Now let's put this back as a fraction. So it's going to look like this. 2x minus 16 over x squared. And actually you'll see that I've rewritten the 2x as 2x over 1 because I'm going to make common denominators. Alright, so if we make common denominators, then the first fraction turns into 2x cubed over x squared. And of course, the whole point of making common denominators is so that we can combine it into a single fraction. Alright, so we're looking for critical numbers. That means we need to see where the derivative doesn't exist and where the derivative is 0. Now the derivative doesn't exist at x equals 0, but that's not in the domain of the function that we were originally considering. Remember, we're only thinking about what happens between 1 and 3. So I'm not going to consider x equals 0 to be a critical number. Now we also need to know where the derivative is 0. So we'll just set the numerator equal to 0. So we set 2x cubed minus 16 equal to 0. And if we work out the algebra, we end up getting that x equals 2. And that's our only critical number. Okay, so now we're going to check the value of the function at the critical numbers and at the endpoints. So we've got our critical number 2. We've got our endpoints 1 and 3. Let's plug all three of those numbers, 1, 2, and 3, back into the original function. So I've done that. I've gone ahead and plugged in 1, 2, and 3. So remember that 1 and 3 were the endpoints, and 2 is the critical number, the only critical number we ended up with. And we plug them in, we get these three values. We got 17, 8, and 97 over 9. You should work out these numbers, make sure they're correct. So really what we're interested in is which of these three numbers is biggest and which is smallest. So that's what we're looking for in our last step. We want to find the smallest and largest outputs. Now I don't know exactly what 97 over 9 is. It's pretty close to 11. It's somewhere between 10 and 11. So that tells me that 8 has to be the smallest number and 17 has to be the largest number of the three outputs. So the absolute minimum is 8, and that occurs at 2. Right, so 8, and it occurs at 2. That was what we had to plug in. And then the absolute maximum is 17, and it occurred at 1. And that's it. That's all we need to do. Okay, that's all for now.